Friday, we started talking about polynomials and their graphs. And so our last question that we did was taking an equation and graphing it. Now we want to go backwards. We want to look at, here's a graph. Can we make an equation for that graph? So, what was the first thing that we talked about on Friday? Huh? And the degree and the leading coefficient tell us what? The end behavior. So on this one, our end behavior is what? Yeah, both ends are pointing up, okay? Which makes sense that they're doing the same thing because they tell us that our degree is what? 8. And then our leading coefficient is going to have to be what if they both point up? Positive. So we just need to make sure that it's positive. You all good with that so far? Then what was the next thing that we talked about? Finding zeros. Okay, so again, we're working our way backwards this time. So from a graph, what are our zeros on the graph? What x values? We got lots of x values. I have lots of points and coordinates on that graph. You're talking about a specific point? You're on the right track. So remember that our x values are also our what on our graph? Our x-intercepts, okay? So we can look at our x-intercepts. Okay, so what's our first x-intercept? Yes. Are we all asleep after the weekend? Alright, so if x equals -3. Yeah, again, remember we're trying to go backwards. So remember that when I factor a polynomial, what do we do with our factors? We set them equal to 0. So what would I have to do in order to make this set equal to 0? Add 3 to both sides. So we get x plus 3 has to equal 0. Are we all okay with that? And so if this equals 0, then that means that this, x plus 3, had to be one of the factors for my function. So again, we're trying to work our way backwards. So I'm starting with my x-intercepts and using those to create our factors. Questions on that? Okay, so what would my next factor be? And then? Yeah, technically x plus 0, so what is x plus 0? Just x. Yeah. Alright, okay, but those are all of our factors. Yes? Do we see where we're getting those factors from? Any more nods or no's? One way or the other? Yes. You mean bouncing? Yeah, we're gonna get to that in a second. That has to do with our exponents, so we're not there yet. But do you understand like where we got these numbers from right now? Okay, that's the biggest part for this right now. We looked at finding our degree when it was in standard form, right? With the like x to the 4th plus 2x squared plus whatever. We just looked at that. Yes. How would I find the degree if something is written in factored form? We could multiply it all out. That's not going to be a whole lot of fun in this case, right? But, like, what could we do that would kind of, like, tell us what we would get if we did multiply it out? Yeah, so, like, here I have, this is x to the 1st, right? This is also x to the 1st, this is x to the 1st, this is x to the 1st. So if we did multiply these out, okay, we would get x times x is x squared times another x is x to the 3rd times another x is x to the 4th. Now you would get a bunch of other stuff besides that, but the front number would be x to the 4th. Are we all with me? So we're just counting the exponents here. and that will give us our degree. But what's the problem right now? It's x to the 4th, and we want x to the 8th. So now going back to what you were talking about earlier, okay? Yes, at -3 and -2, those look different than at 1 and 0. Agreed? They like hit the graph and then come back up. So remember that we said that if a 0 has an odd degree on the outside, it goes through the graph. But if it has an even degree on the outside, it touches it and then goes back up or goes back down, vice versa. So what do we know about -3 and -2? They can be even. So what are even numbers that we could use there? Huh? 2, okay. So we're going to put a 2 on the outside of both of those. Yes. So now what do our exponents add to? No. 2 plus 2 gives us 4, plus another 1 gives us 5, plus 1 more gives us 6. Yes? But what do we notice is happening at 0? Like, what's different about what my graph looks like at 0 versus at -1? Yeah, like it gets really steep, right? So it still goes through it, yes, but it goes through it very, very steep, which tells me that it probably doesn't have an exponent of 1. It has some bigger exponent, okay? Now, it still goes through it, so it still has to be what? Odd. So it would be a bigger odd number that we could use instead of 1. 3. So now, do my exponents as 8. And if for some reason, say like these are both pointing down instead, I can just put a negative symbol on the front, and that would give me a negative leading coefficient. Okay? Now, technically this is one option, okay? If we had not put the 3 there, so say we had changed like one of our 2's to a 4, I also would count that correct, okay? So I'm not going to get super specific. So the things that I'm looking for are 1, do you have the correct factors? Just like the x plus 3, the x plus 2, x plus 1, and x. Okay? 2, do your exponents actually add up to whatever degree they're supposed to add up to? And then 3, are they even and odd where they're supposed to be? Even for the ones that like touch it and come back up, odd for the ones that go through. Okay? So if your exponents were a little bit different, I'm not going to count off for that as long as they still add to 8. Does that make sense? Yes, no, maybe? Alright. Then the last type of problem that we have, okay. So we looked at factoring some stuff that had greatest common factors. We also looked at factoring quadratics, okay. Remember, we also have factoring by grouping, but that's when we have 4 or more terms. So can we factor this by grouping? Do we have 4 or more terms? No. Do we have a common factor here? No. So we have a trinomial. How have we normally factored trinomials? Okay, what's different about this one? Normally we use our AC method on what type of trinomials? Quadratics. Is that a quadratic? No. Does it look kind of like a quadratic though? Yes? Bear with me. Normally a quadratic is like something squared, right? Plus the number times an x plus another number. Agreed? Now, could we rewrite x to the 6th as something squared? What can we rewrite it? X to the 3rd. So what do we notice about the number, or sorry, the x that's in the first spot and our x that's in the second spot? Huh? They're both x cubed. So as long as we can write a function as something squared, and then it's plus that same thing that we were squaring, and then a number on the end, it's in what we call quadratic form. Okay, so we can still factor it the same way that we did with our AC method. So we would be looking at what multiplies together to give us 1, that adds together to give us 2. What do we get? 1 and 1? Now, the only difference here is that instead, normally we would just put an x here. This time, because our thing that was the same for both of them was an x cubed, both of them get an x cubed instead. We can still factor it the same way. Yes. So on our next one, okay, we have an x to the 4th. What can we rewrite x to the 4th as? X squared squared. So then do we have the same thing in our first term and our middle term? And then just a constant? Yeah, so it is in our quadratic form. Now this time we have a 2 in the front, so we do have to do 2 times -3 gives us what? -6. So what multiplies together to give us -6 that adds together to give us 5? -1 and a +6. But when we break it apart, we have to use an x squared this time because that's what was on that middle term. So now, what do my first 2 terms share? 2x squared, and we're left with x squared plus 3. And then what do our second 2 share? Okay, and we're left with? Cool. Well, now what's special about our parentheses? They're the same, so we can factor those out, and we're left with 2x squared minus 1. That's enough. So again, they factor pretty much the same way, it's just you're going to end up with x cubed or x squared. But we can still use our AC method. What questions do we have?